Math Class 31, commutative property. 6 times 7 equals 42, so 7 times 6 equals 42. The commutative property of multiplication states that two numbers can be multiplied in either order, and we still get the same product. Division as unknown factor. Determine which number correctly answers both equations. 32 divided by 8 equals blank, or blank times 8 equals 32. We can make a division problem be an unknown factor problem. 32 is my total, and if I'm dividing or equally sharing that total into 8 groups or groups of 8, I can figure out how many groups there would be. I'm going to take my 32 and equally share them into groups of 8. So I'm going to skip count by 8. 8, 16, 24, 32. Notice I have 4 groups of 8 to be 32. So 4 times 8 equals 32, and 32 divided by 8 is 4. Two-step word problems. Anna had 15 books and 13 comic books in her collection. If she bought 5 more books, how big is her collection in all? Well, Anna has 15 books and 13 comic books. So if we put those together, we're going to add the 15 and 13. And 15 plus 13 is 28. If she bought 5 more books, then we need to add 5 more to that. So I'm going to make this become my new tape diagram. The total 28 books plus 5 more books. Again, I'm adding here to get the total. 28 plus 5 is 33. So Anna has 33 books. Whole numbers as fractions. Use the model to write a fraction for one whole. Notice the model, the whole circle, is broken into 8 equal parts, so our units are eighths, and all 8 parts are shaded. So 8 eighths is equal to one whole. Write a fraction equivalent to 2. If 8 eighths is one whole, then 2 would be 8 eighths and another 8 eighths, which would be 16 eighths. Elapsed time. Write the time shown on each clock. Well, taking a look at the first clock, I see that my hour hand, which is the shorthand, when I'm thinking about time, I look at the shorthand first and then the longhand. The shorthand helps me determine the hour, while the longhand helps me determine the minutes. So looking at the shorthand, I see that it is not quite to the 8. It's at the 7, right past the 7, but not quite at the 8. So it's still in the 7 o'clock hour. And when I look at the longhand, it's pointing at the 10 there. Now at the top of the clock is o'clock, and every minute around the clock is one of these little dots. So when I actually get to a number on the clock, I've passed 5 minutes. So it would be 5, 10, 15, 20, 25, 30 at the bottom of the clock, 35, 40, 45, 50. 7:50 a.m. End time. The shorthand, the hour hand, is on the 9. So it is in the 9 o'clock hour. And the longhand, our minute hand, is on the 1. So it would be 5 minutes past the hour, 9:05 a.m. How much time has passed from start to end? Well, we start at 7:50, and to get to 9:05, I'm going to use the arrow method. If I go to the next hour, that would be 10 minutes, and that would be 8 o'clock. And then I could go to 9 o'clock. That's 1 more hour. And then 5 more minutes would get me to that end time of 9:05. Now, if I add up my time that has elapsed, the 10 minutes, the 1 hour, and the 5 minutes, then 1 hour and 15 minutes has passed. That's the elapsed time. On the back side, measuring capacity and mass. If a student fills the beaker to the arrow, how much water will be in the beaker? Well, our arrow is here, and I see that the beaker is at 100 milliliters for the first tick mark, and I have a 300 milliliter, but in between there's one. So if we've jumped 200 milliliters, but there's one in the middle of those, then that would be 100 milliliters for each tick mark. So this would be 200 milliliters, and this at the arrow would be 400 milliliters. So I'm going to note that for my answer here. 400 milliliters is where the arrow is. The scale shows the weight of the apples. How much do the apples weigh? So notice that the scale is in grams, and at the top of our scale we have 0 grams, and halfway around the scale we're at 250 grams here, and as we continue, a whole rotation on the scale would be 500 grams. Now the arrow is pointing here, and we have this telescope kind of look, or microscope sort of look, I should say, where we have an enlarged picture that helps us see exactly where that point is. And so it's past 140, it's past 145, which would be this middle line right here, right between 140 and 150. It's one tick mark past the 145. So we're going to say 146 grams. Bar graphs, birthday of students by month. I notice that on the vertical axis I have the number of students, and on the horizontal axis I have the months. How many more students have birthdays in December than February? So let's look at December, and I see that the bar goes between 6 and 8. So there are 7 students who have birthdays in December. And in February, the bar goes to the 4. So if I want to know how many more students have birthdays in December than February, I'm going to take 7 and subtract 4. 3 more students, I should say, have birthdays in December. Try this one. How many more students have birthdays in November and December than February? So now I also need to look at the November bar. The November bar goes up to 4 students. So if the question is how many more students have birthdays in November and December, now I'm going to add November, which was 4, and December, which was 7, and that's equal to 11 students. And there were 4 students who had birthdays in February. So I would want to take 11 and subtract 4. And so 7 students, there would be 7 more students who had birthdays in November and December than February. Write the unit form using the given place values. 4,972 is 4,972 ones. 2,467 is hundreds. Now, if hundreds is my greatest unit, then my thousands here have to decompose into hundreds. So I'm going to go all the way to the hundreds. That would be 24 hundreds, 6 tens, 7 ones. 1,536. I want it in hundreds and ones. So again, if hundreds is my greatest unit here, then my thousands need to decompose into hundreds. So I'll go all the way to the hundreds place. That's 15 hundreds, 36